Assalamu alaikum. I am Sabiha Yasmin and my ID is 242155379. Today I am going to present our database management system project MediTrust Pharmacy, which is an admin-centric pharmacy management system. Our project is developed using HTML, CSS, PHP and MySQL, and it runs locally using XAMPP. The main goal of this project is to help pharmacy owners manage medicines, stock, billing, sales efficiently. This project was completed by a team of 5 members. Each member was responsible for a different part of this project. In my part, I worked on the requirement analysis and project planning. Agenda. Now I will briefly explain today's presentation. We will discuss the problem statement, project objectives, project scope, technology stack, system modules, requirement analysis, functional and non-functional requirements, finally the project plan and the deliverables. In the problem statement, many small pharmacies still use notebook or spreadsheet to manage medicine record. Because of this, stock information becomes incorrect, expired medicines are difficult to track, handwritten bills take more time, and the sales reports are difficult to prepare. To solve these problems, we develop an admin-based pharmacy management system. This system stores all information digitally and automatically generates invoice and sales report. In the next slide, the project objectives of our projects are: first, centralize data by storing medicines, suppliers, and sales information in one database. Secondly, the simplify billing by automatically generating invoices. Third, track stack by updating medicines quantity after every sale and giving low stock alert. Finally, enable reporting by displaying sales and stock information in the dashboard. Next, project scope. Our project is designed only for the pharmacy administrators. The system includes admin login, dashboard, medicines management, point of sales, invoice generator, local MySQL database. The project does not include customer login, online payment, mobile application, or any cloud hosting. Next, technology stack. Our project uses 4 main technologies: HTML to create the web pages, CSS to design the user interface, PHP for background logic, MySQL to store all the data. We use XAMPP to run the project locally. System modules. The system contains 4 main modules. The first module is the dashboard, where the admin can see the total sales and stock information. The second module is manage medicines, where medicines can be added, updated, deleted, or searched. The third module is the point of sale, where medicines are selected and sold. The fourth module is invoice, where a bill is automatically generated after each sale. Requirement analysis. Now I will explain my part: requirement analysis and project planning. Before developing any software, we must understand what users actually need. We studied how small pharmacies work and identified common problems such as manual recording, keeping, handwriting bills, and poor stock management. We then listed all the features needed for the system and created a workflow where one admin manages the pharmacy. Functional requirements. Functional requirements describe what the system should do. Our system allows the admin to log in successfully, add, update, delete, or view medicine, search medicines, complete sales using the POS, automatically generate invoice, view sales and stock information on the dashboard. These features make the pharmacy management more easier and faster. Now, the non-functional requirements. The non-functional requirements explain how the system should perform. Our system is easy to use, fast in searching medicines, reliable in maintaining accurate database records, portable because it runs locally using XAMPP without internet. This requirement improves the quality of the software. Now, the project planning. The project was delivered into 5 parts, and for each members, we completed the project step by step. Requirement analysis, database design, database schema, background development, and the front-end design and testing. Our MediTrust Pharmacy Management Systems helps the pharmacies manage medicines, billing, stock, and sales efficiently. It reduces manual work, improves accuracy, and saves time.
Assalamu alaikum. I'm Mohammad Yamin Sadi. My ID is 242-15544. And in this section, I will explain the database design and entity relationship or ER modeling for our pharmacy management system. Before creating the database, we analyze the system requirements and identify the main entities, their attributes, and how they are connected. We then create a ER diagram which acts as a blueprint of our database. From our analysis, we identified seven main entities. The admin entity that stores user who can log into and operate the system. Then next, category entity that stores medicine categorized such as tablets, syrup, and injection. Then we can also see the supplier entity that contain information about the vendor who actually provide the medicines. Then the medicine entity that stores detail of each medicine, including its price, quantity, and quality. Then the sale entity records each customer's transaction made at the point of sale. Then sale item stores the individual medicines included in each sale. Finally, the invoice stores after a transaction the billing document generated after the sale. Here, this diagram shows the diagram of our database. Each rectangle represents a table, while a row inside the represents attribute or columns. The line between tables represent relationship and the labels indicate the cardinality between them. This diagram helps us understand how information flows through the system. Like we can take the supplier and the medicine connections. They have a one supplier can supply many medicines, like for example a supplier can supply paracetamol, napa, ace, and etc. Then we can see the category and medicine connection. Like one category can contain many medicines, like you can take a category table can contain napa, ace, histacin, and many others. And then the sale and sale item connection. One sale may contain multiple medicine items. An example is say sale number 15 has 2 packs of Napa, 1 pack of oat saline, 1 pack of syrup. And so then the medicine and sale item. The same medicine can appear in many different sales. As example, like paracetamol was sold on Monday, Tuesday, Wednesday. Therefore, one medicine can be inside many sale items. Lastly, the sale and invoice. Each completed sale generates exactly one invoice, so they have a one and one connection. Here, this slide summarizes the relationship and their cardinalities. Cardinality describes how many records from one table can be associated with records in another table. As we can see, the first category and medicine relationship, uh, that one category has many medicines. Then the supplier and medicine relationship, like one supplier can supply many medicines. An admin and sale relationship. One admin can make many sales and many sale records in one day. Then we can see sale and sale item relationships. One sale contains many medicines, so there can be many sale items. Then medicine and sale item relationship, and one medicine can appear in many sale items. Lastly, the sale and invoice. Every sale should have a single invoice, so there is a one-on-one relationship in sale and invoice. Here, lastly, to improve database efficiency and avoid redundancy, we apply database normalization. We followed the first three normal forms. At first, normal form means every field contains only one value. For example, we should not store multiple medicine names in one database field separated by commas or any other punctuation marks. Then the second normal form ensures that all non-key attributes depends on entirely on the primary key. This prevents partial dependency and keeps the data organized. Lastly, the third normal form removes unnecessary dependencies. For example, instead of storing the category name repeatedly in the medicine table, we store it once in the category table and reference it using the category ID. This avoids duplication. And lastly, the sale item table is created to resolve many-to-many relationship between sale and medicine. As a customer can buy many medicine in one sale, and one medicine can appear in many different sales. Therefore, sale item acts as a bridge table connection, connecting the sale and medicine. So this is all from me, and thank you for your kind attention. And my next teammate will explain furthermore about the project.
Assalamu alaikum. My name is Sakib Hassan Himel. My ID is 242155327. Now I will explain the database schema implementation and SQL part of our project. This is the core of our pharmacy management system because all the data is stored and managed here. We used MySQL to create our database first. We designed the tables, then we connected them using primary key and foreign keys. This helps us keeping the data organized and prevents unnecessary duplication. Every module of our project depends on this database. For example, when a new medicine is added, the information is stored in the medicine table. When a sale happens, the sale information is saved automatically and stock is updated. We also used SQL queries to perform different operations like inserting new records, updating existing data, searching for medicines, and generating reports. The database schema is the backbone of our project because it allows every feature to work correctly and efficiently. So here you can see the overall database structure. Our project contains 7 tables and each table has specific purpose. The first table is admin. It stores the login information of the system administrator, such as the username and password. The second table is category. It stores different medicine categories like antibiotics, painkillers, vitamins, and so on. The third table is supplier. It stores supplier information, which helps us know where the medicines come from. The fourth table is medicine. This is one of the most important tables because it stores medicine details such as the medicine name, category, supplier, stock, and price. The fifth table is sales. Every time a customer buys medicine, one sales record is created with the sale date and the admin who handled the sale. The sixth table is sale item. It stores the details of each medicine included in a sale. This allows one sale to contain multiple medicines. Finally, we have the invoice table. It stores the invoice number and connects it with the corresponding sale. All these tables are connected using primary keys and foreign keys. This relationship keeps the database accurate and ensures that all the information is linked properly. Now, I will explain some important SQL queries and integrity rules used in our project. The first query updates the medicine stock after every sale. Whenever a customer purchases medicine, the sold quantity is automatically deducted from the available stock. Second query checks for medicines with low stock. If the stock quantity becomes less than 10, the medicine can be shown on the dashboard so that the pharmacy knows it needs to restock it. The third query calculates the total sales of the current day. This helps the pharmacy owner monitor daily business performance. We also use foreign key constraints to maintain data integrity. For example, if a medicine has already been sold, it cannot be deleted from the database. This prevents data inconsistency and protects important sales records. These queries and rules make our system more reliable, accurate, and easy to manage. Thank you. That's all for this part of our presentation.
Hello everyone, myself Farjana Nushin. My ID is 242153839. My part is backend development. Now it connects the HTML or CSS interfaces to the MySQL database, handling login, session operation and sell invoice logic in PHP. Now the backend architecture. Let me start with the architecture. PHP connects to MySQL using MySQL or PDO through a single DB connect PHP file. And then each page like dashboard, medicine or POS has its own PHP script that queries the database and renders HTML. And the third, PHP session start keep the admin logged in across pages. Logout destroys the session. And the fourth, all form input are validated and sanitized before used in SQL queries, prepared statements. And now the crude operation mapping. There is three parts. First one is action, module, and SQL operation. In action, when you add some medicine, it manages the medicine in module section and insert into medicine in the SQL operation. When it edit medicine or stock, it will module the medicine, manage the medicine, and update the medicine set in SQL. When it delete medicine, it manages the medicine in module function and delete from medicine where in SQL function. View or search stock in action. When you will take any action of view or search stock, it module the manage medicine and select where name like. Complete as cell and then module point of cell. In SQL operation, it insert into cells or cell items. And last, the generate invoice, the total counting number of medicine one person can took from a medicine shop. Module the invoice and in SQL function insert into invoice plus select join. Now you will show the dashboard and manage medicine logic. Dashboard in PHP run aggregate queries like sum, count, at page load to show today's sales, stock, value, and alerts. Manage medicine list page. It will select without operational where or like filters for search by category. It will also add or edit form, post data, a PHP handler that validate fields, run, insert, and update. And the last one is deleting a medicine text for existing cell items first to protect or product referential integrity. Now, POS or and invoice generation logic. Admin select one or more medicine and quantities on the POS page. PHP validates stock ability, the calculates subtotal per item and total amount for the sale. A new row is inserted into cells, followed by one row per each item. It also sell in item inside a transaction whenever it will done. And immediately after an invoice row is created, an invoice view or print page is generated using the sale data. That's all about my part. My next team member will explain more. Thank you.
Hello everyone, my name is Aritra Rai. My ID is 242158110. So my topic is front-end design HTML, CSS and testing. Design the admin facing pages and verified the system works correctly end-to-end before the final submission. It is very important for facing the HTML problems that can be solved. Next is pages and navigation flow. First login, second dashboard, third manage medicine, fourth point of sale and fifth invoice. After login, the admin lands on the dashboard and can move freely between manage medicine and POS. Every completed sale routes to its invoice page. Invoice page mainly works through the point of sale that can be reduced through the managed medicine and POS system. And the design considerations. Clean minimal admin dashboard through using plain cascading style sheet, cards for every key numbers, a simple table for stock lists, consistent color scheme and typography across all pages so the interface feels like on product. Forms can use clear labels, and inline validation messages. This stock cannot be negative. Responsive enough layout for a standard desktop browser. Since this runs on a local admin machine, testing plan. This test type and what we can check. Login test. Correction, incorrect credential, empty field, session persistence. CRUD test. Add, edit, delete medicine reflects correctly in the database. POS test. Correct subtotal by total calculation and stock deduction after a sale. Invoice test. Invoice data matches the sale exactly. Items, quantities, totals. Constraint test. Foreign key errors are handled gracefully. Easy deleting a used category. Sample test cases. Scenario expected result. On. Sell more units than in stock. System blocks the sale with a warning. Add medicine with duplicate name. Handled per validation rule. No crash. Delete a category still used by medicine. Blocked by foreign key constraint. Complete a valid sale. Stock reduced, invoice generated correctly. Next is planning. Implementation timeline. Week 1 requirement analysis. Week 2 ER diagram and schema design. Week 3 SQL implementation and testing. Week 4 backend PHP development. Week 5 front-end design and integration. Week 6 system testing and final submission. So what challenges and future scope of this project? Anticipated challenges. Keeping stock quantity accurate across simultaneous sales. Designing a schema flexible enough for expiry and batch tracking. Ensuring PHP forms validate data before it reaches MySQL. Future scope. Multi-admin roles with permission levels, expiry date alerts and batch-wise inventory, sales analytics, charts and PDF invoice export, optional cloud deployment for multi-branch use. Conclusion. MediTrust Pharmacy digitize and admin-only pharmacy workflow. Manage medicine, sell at POS and auto-generated invoices. Build entirely with HTML, CSS, PHP and MySQL. Running locally. Simple, low cost and fully within our course scope. The relational schema. 7 tables and ER diagram ensures data stays consistent, accurate and query ready. Each of the 5 members owns one layer of the system from requirements to testing with SQL design as our core deliverable. It's all about the relational entirely pharmacy digitized system that ensure data with simple, low and many contingency system. Thank you all. So that's all from us. Okay.